We have an empty Unity project opened up. I've just created a new project and set the name as the number link, and there's our sample scene opened up. So we are going to set up our project first. So let's first create our new scene, and we are going to save it inside our scenes folder, and we'll name it as gameplay, and we'll delete our sample scene. And after that, let's change our settings. So let's go inside build settings. Let's remove our sample scene, add our current scene, and we are going to change our build platform to Android. After the platform is changed to Android, we'll start by setting up the project settings. So it will take around 30 seconds. So the platform has changed, and now let's go inside project settings, and for our editor we are going to use underscore naming, and we are going to import text mesh pro and disable the errors. If there are any errors, it won't show up, and that should be it. And then we are going to set up our packages. So we'll remove all the unnecessary packages and only keep the one that are necessary. So we don't need the test framework. Text mesh pro, timeline, and unity UI are going to be needed, so we'll remove the test framework, and we'll remove visual scripting, version control, and the VS Code editor. So let's remove the version control. So every package will take a little bit of time to uninstall depending on your build, PC build. So we'll also remove the visual scripting, and finally we are going to remove the VS Code editor. So it will take a little bit of less load for the script to compile. If we don't need anything, we'll just won't use it. Visual scripting takes it has just so many scripts, and also the build size will be reduced. So we are not going to need any more packages for the project settings. We are also not going to change anything else, and we are also not going to need the build settings. Now let it use the simulator, and let's now bring in the assets. So for the assets, we'll need the editor folder and the resources folder. The editor folder contains the color palette, and the resources folder contains the font and the three assets that we are going to use. And as you can see, it has all the colors that we are going to need. Let's change our main camera color to the white one. There are some dogs barking outside. So after that, let's create our folders and the scripts. So we are going to need one more folder for the prefabs, and another one for our scripts. And let's create both of our scripts. So the first script we are going to need is our game manager, and there are just going to be two scripts, and the second script is going to be our cell script. So that was it for the project setup, and in the next part we'll start by adding mm, creating the basic look of our game. So let's go to the next part. So we have uh, just set up our project and also added our scripts, and we are going to need a couple of objects. So we'll need the game manager, and there is also going to be our background, which is going to need a sprite renderer, and and the sprite we are going to use for it is going to be our square sliced, and it is going to be sliced, and let's make it 4 cross 4, and it is going to be at the back, so let's put it at -10, and the color, it is going to be the dark color. And after that we are going to need the highlight. It is going to be just a simple highlight, so we'll duplicate our bg and we'll rename it that highlight, and our highlight is going to be at 0, and the sprite is going to be our default edge, and the size is going to be 1 cross 4, and this one's color is going to be red, so you'll see why it is that. This is just the sprites, and next we are going to need our cell, so let's create an empty and we'll call it cell, and it is again going to have a sprite renderer attached, and the sprite is going to be our smaller one, and instead of simple it is going to be slice. The color, it's going to be the purplish one, and after that its ordering layer, it's going to be one a little bit higher, so it's on top of our highlight, and after that it is also going to need a box collider 2D, which is going to be a trigger and our cell script. So this is going to be our base prefab that we are going to use. Let's delete it, and we are not going to need any canvas, so we'll just leave as it is. Now let's go inside Visual Studio and we'll just set up our variables first. It's going to be a pretty long list, and we'll see when we'll need to use it. So let's set the variables for our game manager first. So our game manager is going to need a public static game manager instance if we need to reference, public bool for has game finished, and I suppose I didn't change. Yeah, I changed, so doesn't matter. Sometimes I forget to switch tabs for my recorder and it creates problems. And after that we are going to have a serialized field for our private cell, and it is going to be our cell prefab serialized field and private sprite renderer, and this one is going to be our background sprite serialized field private sprite renderer, and this is going to be our highlight sprite and serialized field private vector 2, and it is going to be for our highlight size, so we are going to change its size when we drag around, so it is going to show us an edge, and serialized field private level data, so we'll need to create it and we'll call this level data, and let's create our level data. So it's going to be system.serializable public struct level data, and it's going to have a row column and public int row call and public list of int, which is going to store the data, and we can just call it capital small, doesn't matter. Let's use small row call and data. So we are going to need that, and after that we are going to need a couple of floats. So serialized field private float for our cell gap, and serialized field private float for our cell size, and also we are going to have some gaps around our level, so it is going to be a level gap, and we have stored our level in a list. We'll need to convert it to 2D grid, so we'll call it level grid. And after that we are going to store the cells, so we'll call it cell grid and our start cell, and we'll also need to store our starting position, so it is going to be a vector 2, and we'll call the start pose burst dot intrinsics, don't need it, system dot collections dot generic, and after that we are going to have a private list which is going to be a vector 2 int. So we are going to have the simple integer for directions, so we'll need to convert those directions into the offsets for our grid. So if it is to the right, then it is going to have an offset of up, cause we need to move the column and our column is stored in the y-axis. So 0 is right, then we are going to have up, it's just going to row increase, so it's going to be right, and similarly left, and left is going to have down cause it is 0 and -1, and our -1 is left has -1, and in our grid we need to convert रिकॉर्डिंग करने बैठा हो, अरे जल्दी बोल रहे हैं, तो यूट्यूब का रिकॉर्डिंग करने बैठा हो, आज नहीं, अभी कहाँ से निकलूंगा मैं, हाँ तो रोक, हाँ। So I just had a call and our left, so inside our grid the for third direction is going to be the bottom, and the bottom has -1 and 0, so the row is going to change, so it has the left, and the left has vector 2 int of -1 and 0, so that's why those directions are there. So don't mess up with how the directions work. And after that we are going to set up our cells, and it is going to be a long one, so let's create a hidden inspector, and it's going to be a public int number, and for now let's just add a getter and a setter. It is going to have some different logic. Then let's add a hidden inspector public int for the row, so I'm just setting it at start, so whenever we code we will use afterwards. And now we are going to have a serialized field tmp text, and it is going to be our number text, so our cell is going to show some numbers. Serialized field private sprite renderer, and this is going to be our cell sprite, so it is going to show different colors if we just add any extra edge, or if it is empty. And after that we are going to have a serialized field private game object, and we are going to go from right 1 and then right 2, then we are going to have for top 1, top 2, bottom 1, bottom 2, and so let's not mess up. Serialized field and private game object left one, and we are going to have left two. So these are going to be edges showing if we have one or two edge. So if there is a single edge, then our right one is going to show up. If there are two edges, then the right two is going to show up. And let's create a color. So these are for the color states. So one is going to have a default color, then we are going to have one for our salt color. So if the cell is salt, so if it is turned 0, then incorrect color. So if it is incorrect, it has gone negative, then it is going to show red. And private int for a number, and private dictionary, which is going to go from integer to dictionary of int and into game object. So it is going to go for each of the directions, so edges. So 0 is for the right, so it will go for the 0 direction, and if we have one or two edge, then it is going to show the respective game object. So if we pass edges of 0 comma 1, then it is going to go in the 0 direction, and it is going to turn on the edge which just has one edge. And after that, we are going to have an int for our edge counts. So how many edges do we have? We'll need to store it so we can know. This is just for the reference for the game objects. And after that, we are going to have a dictionary for the directions to cells. So if any of the cell is connected, then we can check here. If it is not connected, then we don't need to update. And then we are going to have a private int for number. Yeah, we had a number. So private const, and we are going to have an integer. First right is going to be 0, top is going to be 1, bottom is going to be 3, and our left it is going to be 2. So 0 1 2 3, as you can see, it is moving in the counterclockwise direction. And that should be it for our initial variables, and it was pretty long. So as long as I don't mess up, it will be perfectly fine, and we'll see how we are going to use them. So just copy, and if you want, you can just directly copy paste from the script. So has game finished and all the references, and in the next part we'll try spawning our baseboard. So we added all the variables. Now let's spawn our board first. So it is going to be the easiest one. We just need to rearrange the background and spawn the cells at the correct position. And we'll set up the initialization part later. So we'll see what we need to do. So first we are going to have our awake, and our instance is going to be set to this, and our has game finished is going to be false. And after that, we are going to hide our highlight sprite. So highlight sprite dot game object dot set active, it is going to be false. And after that, let's set our grid. So we'll set up our cell grid. So our cell grid is going to be new cell, and here we are going to pass our level data dot row and our level data dot call. So Yeah, and we also need to upgrade our level grid, and our level grid is going to be similarly new int. Why is this autocorrect not working correctly? So it is going to be new int, and similarly is going to be a 2D array of our level data dot row and our level data dot call. And we need to set up our level grid. So let's level data dot row, and for int j is equals to 0 level data dot call, and our cell grid of I comma j is going to be equal to our level data and I multiplied by level data dot row. So how many rows there are, and we'll add j, so it is going to give us all the columns. And cannot implicitly convert, okay, level grid. So it is going to set up our level grid. Previously we had it as a list of integers, and they are going to go from 0 0 first row, second row, third row, fourth row. So that's how they are going to be aligned there, and after that we'll spawn the level. So we'll need to create our function. So private void spawn level, and inside our spawn level we need to set up our background first. So our background needs to be centered, so currently it will be at 0 0 position and not aligned. So cell size plus cell gap and plus level multiplied by level data dot column. So our width is going to be the column size, and we'll subtract cell gap, and finally we'll add our level gap. Similarly our height is going to be instead of multiplying by column, we'll multiply by row, and minus cell gap plus level gap, and not level gap dot row, level data dot row. And after that we will set up our background sprite size. So background sprite dot size is going to be our new vector 2 of width and height, and we also need to set up our position. So we'll call it background position, and it's going to be new vector 3, and the x value is going to be width divided by 2f minus cell size divided by 2f, and finally we'll also need to subtract our level gap divided by 2f. So these are the values I found out by experimenting. So what was having the offset, and similarly as our grid is going to be square, so uh, it is supposed to be square, so we are going to have width divided by 2f. So x position is going to be the width, and we could have height here, but I'm not going to use any squarish, not squarish, any rectangle type grid. So it is going to work for any square grid. And camera dot main, let's set our orthographic size, and it is going to be our width multiplied by 1.2f, and our camera dot main dot transform dot position, we need to set our background position first. So new vector 3, there is a 0 remaining, and after that yeah, we'll need to set up our background position first. So our background sprite dot transform dot position is going to be our background position, and our camera's transform position is going to be new vector 3. We are going to copy the background positions x and y value, and the z is going to be at -10f. So our camera and background is set up. Now we need to spawn all of our sprites. So for int I is equals to 0, I less than level data dot row, and for int j is equals to 0, j less than level data dot call. And let's get our spawn position first. So spawn pos is going to be start pose, and we'll need to create our start position. So v3 start pose is going to be our 0. It starts at 0. Then we are going to have our right offset, and it's going to be right multiplied by our cell size plus cell gap. And similarly our top offset is going to be up multiplied by cell size plus cell gap, and it is going to have the start position plus our j multiplied by right offset. So our columns have the right offset plus our top offset multiplied by I multiplied by top offset. So our first row is going to be at 0, second row is going to be at above that, and our third row is going to be above that, and after that we are going to spawn it. So our cell temp cell is going to be equal to instantiate, and we'll need to instantiate our cell prefab at our spawn pose at quaternion.identity, and after that we'll need to set our cell grid of I and j to be equal to our temporary cell, and if our temporary cell dot number is equals to 0, then we'll destroy it. 0 doesn't have any cells there, so at start it is 0, we don't need to do anything, and we'll also need to reset the I and j to be equal to null. And before that we need to initialize with the number. So let's create our temp cell dot number is going to be from our level grid of I and j. So it should spawn everything, and let's see if it shows us any errors. So that is our game manager. The cell size, cell gap and level gap is going to be 2. Highlight size, let's set it at 1 and 2. We are going to have our highlight and the background sprite. Did I change? Yep. And our cell prefab is going to be our cell has that needs to be hide in inspector, so it doesn't show up. So it will reload in a second, so faster reloads if you have less packages. And after that our cell doesn't have anything, so let's hit play and let's see if our crashes. So it didn't crash, but it didn't even do anything. There was no level, so that why it didn't do anything. So we need to update our level data. So let's add 3 and 3, and our data is going to have let's see what was the values. So 2 3 0 3 4 3 3 7 3, and finally 2 3 2. And let's now hit play, so it should show us a grid, and as you can see, here it was 0, so that's why it was not updated. So let's update to 2, so we should be able to see the grid. So our grid is spawned. Now what we need to do is show the correct values, and our grid doesn't look good right now, so we need to also update ourselves to have all this game objects. So these are for the edges. So as you can see, we are going to have an edge here. This one is here and highlight, but we are going to have edges there. So that was it for this part, and we spawned our cells, realigned our game objects, which is our background and the camera, so it fits perfectly. And in the next part we'll initialize our cell prefab. So in the previous part, we spawned our board. Now what we need to do is set up the variables for our cells. So it has so many of these values unassigned. So we can assign our cell sprite first, and the default color is going to be gray, uh, purplish white, and the salt color is going to be blue, and our incorrect color is going to be red. And as you can see, we have couple of our prefabs. So let's create our text, and our canvas is going to be world space, and the size is going to be 2x2. Position, let's set it to 0. And as you can see, that is our canvas, and order in layer, it's going to be highest at 10. And similarly, we need to realign our text, so let's have it 2x2, have it auto size, and we'll set the min to 0 and max to 10. Have it aligned to the center, change the color to our dark one, change our font to Alata, and change the text to 9, and have it bold. So this is going to be our text, and it needs to have a text attached. So let's attach the text, and after that we'll need to create our edges. So let's create our first edge. So we'll create an empty, and we'll rename it as right_1. It is going to be the right one, and our right is going to have a prefab, and mm, the prefab is just going to be the edge. And let's attach a sprite renderer component, and for the sprite we are going to use our default edge, and we'll make it sliced. So as you can see, it is looking a little bit better, and we'll make it the white color. So currently this is our sprite, and the total size is going to be 4, and this one is going to be our right, but it is not at right. We need to set the rotation to -90, so it is going to be aligned at right. And after that we'll duplicate our right, and we'll align it at 0. So this is going to be our top, and after that we are going to have all of our edges. Top one, and let's duplicate our top 2. This is going to be our left one, and it is going to have a rotation of 90. And again, if we duplicate left 2, we are going to have bottom one, and it is going to have 180. And if we duplicate all 4 of them, and it automatically named it for us. And now what we need to do is change its position to -0.33, and we'll duplicate our edge and change it to positive. And similarly we'll do it for rest of the edges. So we are going to have 3 edge. So this one is going to be at positive 0.33, and this one is going to be at negative 0.33. And similarly let's add it here, negative 0.33, and if we duplicate, and positive 0.33. And similarly for the bottom one, negative 0.33, and doesn't matter, both of them are going to be shown at once. So positive 0.33, we need to forgot one more 3 here. And now what would happen is we will be able to see all of those edges, and that's what these edges are going to do. So we'll need to show our edges if there is an edge in between. And as you can see, our text is a little bit yeah, it is good. No issues here. So 128, mm, maybe because let's change it to iPhone 13 fit to screen. And now let's change our text, so it's just showing here only, there are not any problems. And as you can see, these edges are not going to be shown at the start. We are going to turn them off, but we'll need to resize them so they don't uh, by default they are sliced, so it will be at 0.25 cross 2. It is going to be different for different sizes. So if there is no cell here, then we are going to need an edge from here to here, so depending on the gap we are going to have that size. So let's code that. So we'll go inside Visual Studio, and for our cell we'll need to create our initializer, and also we'll need to update if yeah, we need to also update the adjacents. So first we need to spawn all of the cells, and then we need to connect all of the cells. So let's create an initializer function in our cell. So public void init, and here we are going to pass row call, and finally for our number, and our not number, our number is going to be num, and before that here we add a default getter and setter. So let's update that. So here inside our getter we are just going to return the number, but inside our setter our number is going to be a value, and our number text.text is going to be number.toString. And after that if our number is 0, then our cell sprite.color is going to be equal to our solved color, so it is going to be solved. And we need to hide our number text, so it is number text dot game object dot set actor to false. Else if our number is less than 0, that means it is negative, so the color is going to be equal to our incorrect color. And similarly we are not going to show number text, as that means it is greater than 0, then it is going to be our default color. And our number text now we need to show, so we need to show that number. And inside our initialized we'll set the number to num, row to row, and our column to our call. And after that our h counts is going to be our new dictionary of end to end, and our h counts of right is going to be equal to 0, and left is going to be equal to 0, top and bottom are going to be equal to 0. We also need to set our connected cells. After setting up our connected cells we need to set all of them to null, so left is going to be equal to null, top, bottom and right. So all 4 directions are going to be null at start. So right, left, top, bottom. So all four directions are included. And after that we need to set up our edges. So our edges is going to be a new dictionary, and after that we need to set our right. So our edges of right is going to be new dictionary, and our edges of right, so for the right, our one is going to be our game object, which is going to be right one, edges right 2, and we'll set our edges of top is going to be new dictionary, top 1 and top 2. Now we need to set edges of our left, and it is going to be a new dictionary, left 1 and left 2. So sometimes autocorrect helps. And finally we are going to have set also the bottom. So bottom is going to be new dictionary, bottom 1 and bottom 2. So mm, bottom 1 and this one is going to be bottom 2. So all of them are aligned correctly. And what it's going to be used for is if we create a new edge, then what we are going to do is we'll go the directions, turn off both of the edges, and pass the number of edge counts which we have stored for each of the directions, and we'll only turn off the that edge. So I'm doing it by code here because our dictionary is not going to be serializable, and there will be it would be difficult to it would have been easier to like set it up in the inspector, but as you know, dictionaries are non-serializable, and inside our dictionary we have another dictionary which points to a game object, so we'll need to create a new struct. Instead we'll just save it as a dictionary and we'll directly assign by code. So this is going to happen on initialization, and after that inside our initialization, instead of setting the numbers, what we are going to do is we'll initialize by our ing. So we'll pass I comma j comma our level grid. So it should set everything up. Let's go inside Unity and let's see if we can see all the numbers. So let's hit play, and if there are not any errors, then we should be able to see the numbers. So as you can see, numbers are all shown up, and they should be connected. And now what we need to do is connect all the edges. So to connect the edges, we will need another function for our cell. It is again going to be called init, but here we are going to initialize our connected cell. So we'll need to run through the loop again. So previously the cell grid was not assigned, so that's why we cannot connect it, but now it is going to be assigned. So level data dot row and one more loop, level data dot column, and here we need to check if it is null, because some values will be empty as we would have destroyed it. So so if our cell grid at I comma j is not equal to null, then cell grid at ij dot init. Yeah, this one will also belong. So in our current initialization, what we are going to do is turn off every edge and set up the sizes, cause there may be some variable size. Get direction, offset, get direction, check when. public bool is valid, and public cell get adjacent cell. So we'll need that, and spawning is done. Yeah, we'll need to create both of those, but before that, let's set up our init. So what is going to happen in our initializer? So we are going to go through all four of the directions, and our connected cell is going to be equal to game manager dot instance, and get adjacent cell. Yeah, we'll need to create both of those functions first. So let's create both of those functions, and they are going to be the get adjacent cells and our is valid cell. So let's create our public bool is valid, and it is going to take a vector to int, and we'll call it pause, and we are going to return the result. Not the result. So it is going to denote the row and the column. So return pose dot x is greater than 0 and pose dot y is greater than 0 and greater or equal to 0. Our pose dot x is less than level data dot row, and our pose dot y is less than level data dot call. So it is going to be valid if we pass any row and the column as a vector to int. And now we are going to need a public cell get adjacent cell, and here we are going to pass our row, column, and also the direction. So in which direction we need to go, and we need to convert this direction into our offset. So that's why we created our private list. So for the direction 0, it is going to be offset by one column, so it is going to be 0 1, and 0 1 converted to vector 2 int is going to up. So right is converted to up is converted to right, left is converted to down, and down is converted to left. Just remember that. So we'll create our vector2 int current direction is going to be our directions of direction. Vector2 int starting position is going to be new vector2 int of row and the column. Vector2 int our checking position is going to be our starting position plus our current direction, and while is valid our checking position is going to be added our current direction, and also if it is null, so cell grid at our checkpose.x and checkpose.y is null. So what it is going to do is it will go through the whole direction and find the first non-empty non-null cell, and after it is done we'll check if our check pose is valid, then we are going to return the cell grid at our checkpose.x and checkpose.y, or we are going to return null. So if it had been null, then it would be outside the bounds and it would be invalid, so that is going to return the adjacent cell for the direction. And after we get the adjacent cell for our row, our column, and I, we need to check if it is null. So if it is null, then we are going to continue the loop. We don't need to do anything. So if connected cell of I is equals to null, then continue. Else what we need to do is get our single edge. So our single edge is going to be from our edges of I, and one dot get component in children, and we need to find our sprite renderer. And after finding our sprite renderer, so double edges is going to be edges I and 2 dot get components in children, and this is going to be our sprite renderer. So vector2int edge offset is going to be equal to new vector2int, and here for the x and the y value we are going to pass the row and the column. So it is going to set up the size. So connected cell of I dot row minus row, connected cell of I dot column minus column. So it is going to get that offset, and after getting that offset we need to create our edge size. So if our mathf dot abs of edge offset dot x is greater than mathf dot abs of edge offset dot y, then it is going to be equal to mathf dot abs of edge offset dot x, as it is going to be equal to mathf dot abs of edge offset dot y. So that's going to be the edge size. We need to multiply the edge size by game manager dot instance dot we forgot to create edge size, so that should be at the start. So public float edge size, and it is going to be our cell gap plus cell size. And after that we need to create one more function. So private void change sprite size, and the only thing that we need to pass is the sprite and the size. So sprite and our float size, and what we are going to do is sprite dot size is going to be sprite dot size is going to be new vector2 sprite dot size dot x, and the y is going to be size. So we'll change the size of our single edge. It is a single sprite renderer to edge size, and for each item in our double edges we'll change the sprite sizes item to edge size. And after all of that is done for each of the directions, we'll need to turn everything off off. So right one dot set active to false, right two dot set active to false, bottom one, bottom two, left one dot set active to false, left two dot set active to false, and top one dot set active to false, and top two dot set active to false. And after everything is done, so this one was pretty long, so it was just the initialization. And let's see if we get any errors first. So everything is turned off, everything is turned on, no errors, and the variable right one of cell has not been assigned. Okay, so we need to assign every variable inside our cell. So let's go inside our prefab, this in, and let's assign everything. So first we are going to assign the right one, then the top one, then left one, bottom one, right two, top two, left two, and finally bottom two. So now everything is assigned, and if there is anything remaining then it will crash, but it did not crash, so everything was assigned perfectly and it did not show any error. And to check one more thing, let's set our fifth value to be 0, so we can know like what is currently happening, and still it is getting connected. So it is still connected, it would be, but we won't be able to check afterwards, so we'll check it later. And currently it's not showing any errors and everything's connected perfectly fine. And in the next part we'll start adding the inputs, and we'll see how it is going to, how all of our edges are going to behave. So let's go to the next part. So in the previous part we initialized all of our cells. Now what we need to do is set up a method to add or remove the edges, so we are going to add that. So let's create all the methods for our cell. That's why the system was added. And so public bool, and we are going to check is valid cell, and let's pass the cell and pass the direction. So if the cell matches the direction, so our connected cell at direction is equals to cell. So I'll just add all the functions we'll be needing. Let's add our first function, which is going to be for adding an edge, and we are going to pass our direction. And if our connected cell at our direction is equals to null, then we are going to return. Else if our edge counts at direction is going to be 2, so it has max, then also we are going to return. Else what we'll do is edge counts at direction plus plus, the number is going to decrease, and our edges at direction of 1 dot set active to false, so we'll turn both of them false, and our edges at direction and 2 is also turned false. And we are adding edges, so we'll just direction for our edge counts at direction, so these are going to be the number of edges, and we'll turn it true. Set active to true. So that's our edge is going to be added, and next we need to add the remove edge, and let's pass the remove edge of direction and remove edge of direction. So it is going to remove the edge, and to remove edge we need to first check if our connected cell at direction is equals to null, then we are going to return, or our edge counts of direction is 0, then we cannot remove anything. So if any of the condition is satisfied, then we are going to return. And if it is not, then we'll decrease the edge count dictionary. So edge count at direction minus minus number is going to be increased, and similar steps, we'll just copy everything, and this is only going to work if edge counts at direction is equals to 0. Then we are going to return. We don't if it is not equal to 0, then we are going to show that edge. And similarly, remove edges is going to work. So public void remove all edges, and here what we are going to do is we are going to pass all 4 directions, and we'll call our remove edge, and we'll pass the eye, and similarly we'll call the remove edge and we'll pass the eye. So it is going to remove all 4 of the edges, and adding and removing function, as you can see, it is pretty straightforward. It is going to turn on and off all those edges. Now the core logic is going to be inside our game manager. We are going to detect everything that inside our update function. So let's go inside update. So it is going to be a pretty long one, and let's create is valid adjacent cell spawn level. So let's add our update here, and if our game has finished, then we are going to return, and first input dot get mouse button down of 0, else if input dot get mouse button of 0, so it is going to be for the dragging, else if input dot get mouse button up of 0. So let's see how we are going to first add all of the edges. So when our mouse button down is 0, we'll first set the start cell to be null, and so it was, yeah, so our start cell to be null. Let's get our mouse position, and it is going to be from our camera dot main dot screen to world point, and we are going to pass our input dot mouse position v2, will convert it to vector2, and it is going to be for our mouse pose dot x and y, and after converting to a vector2, we'll create a raycast at 2D, and we'll call it hit, and it is going to be from the physics 2D dot raycast. We'll pass our mouse position in the 0 direction, and if we are hitting, and hit dot collider dot try get component, and out is going to be our starting cell. So if we have connected anything, then our highlight sprite dot game object set active is going to be true, and our highlight sprite dot size is going to be our highlight size, and our highlight sprite dot transform dot position is going to be start cell dot transform dot position. If we have not hit anything, then we need to remove if we are colliding with any of the edges, but we'll do it afterwards. And here for now will not do anything, but if our start cell is equals to null, then we are going to return. Similarly, if our start cell is going to be null, then we are going to return, and voila, 0 errors. Okay, so there are not any errors. Now what would happen when we are dragging? So we need to update our highlights size. So let's create our mouse pose, and it is going to be camera dot main. I'm lazy, so let's copy both of these lines here, m2d, and we'll create a vector2 offset is going to be equal to mouse pose 2d minus starting position. We also need to set our starting position. So our starting position is nope. Starting position is going to be mouse pose 2d, and our offset is going to be mouse pose 2d minus starting position. And after that, let's create a v2 end of offset direction, so in which direction it is going, and we'll need to create a function for that, and we'll call it get direction for the offset. And after we have converted a vector2 end, we'll convert it to offset value, and we'll call this function get offset, and here we need to pass both our offset and the offset direction, and finally we'll convert it to a direction index, and here we are going to pass our offset direction. So depending on the offset direction, it is going to return us the direction index, which are the 0, 1, 2, 3 and 4. Now let's create our vector3 angle is going to be no. Where did it go? Vector3 new vector3 0, 0, 90f multiplied by direction index -1, and after setting the angle, we need to set the highlight sprite dot size is going to be equal to new vector2 highlight size dot x, and offset value, and finally our highlight sprite transform dot Euler angles is going to be equal to angle. So we'll need to create the get direction index. So let's create that. The easiest one is the get direction index. So private int get direction index. So we can just directly use where it is. So let's create our get direction index, and will y I and t end result is going to be equal to 0, and if our offset direction is equal to right, then return 0. The result is going to be 0. Return result, and if our offset direction is left, then result is going to be 2. If our offset direction is up, then result is 1, and if our offset direction is down, then our result is going to be 3. So these are the directions that we have passed, and after that we need to set our get offset for the direction. So float result is going to be 0, and if our offset direction is equals to left, or our offset direction is equals to right, so we are going to set the result to be equal to mathf dot abs of our offset dot x, and similarly if our offset direction is going to be equal to up or down, then our result is going to be mathf dot abs of offset dot y, and we are going to return the result. And to get the direction, this one is going to be a little bit complicated. So what it is doing is it is just multiplying and returning the offset values. We can use the dot product, but let's leave as. And here also I can use just a list and return the index of that list, but this one is better for understanding. And inside our direction we need to convert an offset to a direction, so we do int of result is going to be equal to 0, and we are going to return the result. Now how if our mathf dot abs of offset dot y is greater than offset dot x, and offset dot y is greater than 0, then we'll set our result to be equal to up. And similarly, if mathf dot abs of offset dot y is greater than offset dot x and offset dot y is less than 0, then our result is going to be down. Let's just copy both of them, and here instead of greater we are going to use less and less, so x is greater, and instead of checking on x we are going to check x, so it is going to return right, and this one is going to return left. And there's already too much code. So we don't have an option for checking if anything is working correctly right now. So let's go inside Unity and let's see if everything's working. So what should happen is for now we should be able to see our highlight. So as you can see, we are able to see the highlight expanding in all four of the directions. It is not turned off because we don't have an option to turn it off. So our highlight is working perfectly fine. Now what we need to do is update the edges. So let's go inside Visual Studio, and I think yeah, this would also be done pretty fast. So let's create our private void check when, and has game finished is going to be true, and for int I is equals to 0, I less than level data dot row, for int j is equals to 0, j less than level data dot call, if cell grid of I and j is not equal to null, and cell grid of I and j dot number is not equal to 0, then instead of continue we are just directly going to return. So this is going to check the winning condition, and let's add check win. So when our input dot mouse button up, let's see what we hear else. So here what we were going to do is we are going to create one more head. So it is going to be physics 2d dot raycast, and we are going to raycast from mouse pose to left, and if hit, and so if we have hit and hit dot game hit dot collider dot try get component out start cell. So this is the left, then start cell dot remove at 0. And let's copy this multiple times. So we are going to remove edges on 4 of the directions. So this one is for the left, and next we'll go down, so it is down, then the direction in which the edge should be removed is up. Then we will go right, so the edge moving direction is 2, which should be the left. So if we are hitting the right, then whatever is at the right we are going to remove its left edge, and similarly we'll go up, then we are going to remove the bottom edge, and if it has edge then only we are going to remove. If it does not, then it is not going to do anything, and at the end we'll set the start cell to null. So we'll set the start cell to null, and so this should be the last part. I think it should be done pretty fast. And now let's see what we need to do first. So let's copy the raycast, and after raycasting, so if we hit and hit dot collider dot try get component out cell, and this is going to be our end cell. So we have hit an ending cell, then if our end cell is going to be our start cell, then we need to remove all edges on our starting cell, and we need to remove all edges for its adjacent cells. So we need to create a for loop, and let's get the adjacent cell, and it should be for get adjacent cell, and we need to pass our start cell dot row, start cell dot column, and the direction is going to be IA. And if our adjacent cell is not equal to null, then int adjacent direction is going to be equal to I plus 2 %4. So this is going to be the direction, and what we'll do is adjacent cell dot remove edge, and we'll pass the adjacent direction, and paste it again, and it should remove the edge. But if it is not removing, then what we are going to do is else let's create our offset, and our offset is going to be our mouse pose 2D, and we'll subtract our start pose. Again, it includes the system.numerics. We don't need it, don't recommend it. And we are going to get the offset direction, and it is going to be the get direction of offset. And after getting the direction, we can get the direction index, which should be get direction index, and we need to pass the offset direction. And if our start cell dot is valid cell, and we need to pass our ending cell and our direction index, then we'll start cell dot add edge, we need to add to the direction, and also our end cell dot add edge plus 2 and %4. So it is going to add both of the edges, and our start cell should be null. Before check when our start cell is going to be null, our highlight dot game object dot set actor is going to be false. So again, pretty much most of the coding part, and I think that should be the final piece of code that needs to be integrated. And these are just additional conditions, and I'll need to update the size a little bit, so the values are not perfectly fine. So as you can see, we can create the edges, we can create the edge here, we can create the edge here, we can move one of the edges, we can clear all of the edges, and one. So that has two, three, one. Yeah, so the game is not getting completed because the values are not the correct values. And let me finally add the correct values if I can find. So let's get the notes. Where was it? So they should be 2, and so it is 220474 2 mm, mm, mm. So 22047 4 and 232. So let's see how this works. So let's first connect every edge, and one here, and yeah, so this one should be it, and this one needs to have one more, so it needs to be connected here, needs to be connected here, and we'll delete here. So now the game is finished and we cannot reset anywhere, and that may not, yeah, so that was the final solution, and let's play the game again, and we uh, added all the functionalities that we needed. So let's connect everything. This is the highlight, and as you can see, if we didn't add for a valid cell for the direction, this would have created problems, but now it didn't. So this one needs 2, this one needs 3, one here. Mm, 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 mm. So the game is finished, and this is a valid solution, and I just added some random values, and it's a puzzle game, so there are going to be different solutions for each of the boards, as we just handcrafted all the puzzles here. And that was it for this part, and if you watched till the end, then do like the video, subscribe to the channel, and this is available completely free on YouTube, but if you want to buy it and support the channel, then you can completely buy it on the Udemy link, which should be down below. And thank you for watching.